how you doing? My name is Arturo Gutierrez. I'm going to give the video explanation for quiz 1, uh, Civil Engineering 532. Here's question 1. And then I'm just going to go ahead and show you question 2. So I'll start with the first one. So the first one, we're asked to find a mathematical expression for the resultant wave involving products of sine and cosine. So we're giving two tidal constituents, and with those, what we're going to do is we're going to use trigonometric identities, the law of sines, given in lecture 1C. So basically, we're going to use the identity to get down to our mathematical expression. So n equals a sine 2 pi 12ht plus a sine 2 pi 12.42ht. We break that down as the expression follows. So a plus b divided by 2, and then a minus b divided by 2. So you can see here we get down to n equals 2a sine 0.5147 ht cosine 0.0089 ht. So we take we take basically our w and our t, which are w and our t, that's going to give us the angular frequency. So for the first one, sine 0.5147, that's going to be our angular frequency, and then we can plug that into t equals 2 pi over angular frequency, which is w, to give us the period. So that one's going to give us our first one, which is t sine 12.207 hours, and you want it converted to days. So 12.207 hours is going to give us basically half a day, 0.5086 days, and that's going to be for t sine. We're going to do the same thing with our cosine function. So that 0.0089 ht is going to be our, without the t, is going to be our angular frequency. We're going to plug that into t equals 2 pi over w in order to find our period for the cosine. So t cosine is going to equal 705.975 hours. We're going to convert that to days divided by 24 hours. It's going to give us 29.416 days. So our period for the corresponding cosine function is going to be t cosine equals 29.416 days. So those are our two corresponding periods for the sine and for the cosine. And the question is, which one is the longest? Express them in days. So that's going to be, the longest one is going to be our cosine. Yeah, it's going to be our period corresponding to the cosine function, which is again t cosine equals 29.416 days. So that's the first one. For the second one, we're asked to write an explicit mathematical expression of a wave moving in the xy plane. So it's going to be moving in two dimensions. We're given some parameters: height, wavelength. So height of 2 meters, wavelength 100 meters, period 15 seconds. It's propagating with respect to the x-axis in 30 degrees, and phase shift of 0. So we're going to use some of the formulas given in lecture 1C to find some of the missing missing attributes. So we can set it up to find amplitude h over 2. That's going to give us 1 meter. And then we can use, to find the wave number k, we could use k equals 2 pi over L, which is going to be the wavelength. So we have 2 pi over L. It's going to give us our wave number, which is k. So we have k equals 0.0628 radian per meter. And then last is going to be our angular frequency, which is our w. So since we're given the period t, we could plug that in. So w equals 2 pi over t. And that's going to give us our W angular frequency of 0.4189 radians per second. Now, since it's propagating at 30 degrees, we need to find, basically the kx and the ky. So we're going to use our wave number of k. We're going to plug it in again into one of those equations. So it's going to be k of x is going to equal k cosine of the angle. K of y is k sine of the angle. So it's going to be 0.0628 cosine 30, 0.0628 sine 30. And then we're going to plug that in into the provided mathematical equation. So it's going to be n equals h over 2, which is basically the amplitude, cosine k of x, x, k of y, y, minus w, which is frequency t. So we plug those in, and we're going to get n equals 1 cosine 0.0543x plus 0.0314y minus 0.4189t, which is the exact stuff that I have on here. So that's the explanation for both of them. For both problems, the equations and the information was found both in lecture 1C and like the second half of the slides. Thank you.